All right, now we're looking at a problem that's a little bit wordy, so we'll start by breaking it down, adding some information to the diagram. The relationship between three stars in our galaxy is shown below in this diagram here. All of the stars lie in the same two-dimensional plane. Star A is 6.2 times 10 to the 4 light years from star B. Okay, let's start with that. Star A to star B is 6.2 times 10 to the 4 light years. Okay, and 8.9 times 10 to the 4 light years from C. So 8.9 times 10 to the 4 light years from C. We want to calculate angle ACB. ACB. That's this one here. Okay. It's not a right angle triangle, so we can't use the basic sine, cosine, and tangent ratios. Over here, we have a side and its corresponding angles, which we don't know. Let's call it x. Here, you have an angle and its corresponding side. So we have one piece of corresponding information from the triangle. Therefore, we can use the sine rule. Since we want the unknown angle, I'm going to put the sine rule on the top. So sine of 115 over this side here, 8.9 times 10 to the 4 is equal to what we don't know over 6.2 times 10 to the 4. Okay, this is what we don't know. Opposite or corresponding side, sorry, is 6.2 times 10 to the 4. All right, now we've got some big numbers, but we'll deal with it using the calculator. We need to multiply both sides by 6.2 times 10 to the 4, and that is sine x. Okay, so let's start. Sine 115 divided by bracket 8.9 times 10 to the power of 4. Okay, then we're going to take that result and multiply it by, in brackets, 6.2 times 10 to the power of 4. Okay, check that looks okay. Yes, good. Okay, so 0.6313 is sine of x. In order to find the angle, we use inverse sine, 0.6313. That will give us x. Okay, and we need this. We can use the answer key, and we won't round until the very end. So 39.2 degrees is angle ACB. Excellent. That's part A. Then, in part B, we want to calculate the distance between star B and star C. So this distance here, let's call it y. Write your answer in scientific notation. Okay, so I want this piece of information. I have this angle and this angle. These are corresponding. I now have this angle and this angle, but I don't have that one. However, a very simple property, angles in a triangle add up to 180. So 180, take away 115, subtract 39.2, subtract 115, subtract 39.2, and we get that last angle 25.8. So that angle is this angle. Okay, now suddenly we have a corresponding angle to this side that we don't know. So let's set it up. Y divided by sine 25.8, corresponding sine rule. And now we can pick either these sides or those sides. I'm going to pick these ones because then there's no rounding that's been done. Okay, so this length here, 8.9 times 10 to the 4 divided by sine 115. In order to solve for y, we take 8.9 times 10 to the 4, divide sine 115, and multiply by sine 25.8. Good. Remember, put the top in brackets, 8.9 times 10 to the 4, divided by sine 115 times sine 25.8. Oops. Okay, check. This makes sense. Divide times excellent. Okay. Wow, that's a big number. Now, remember that I want my answer in scientific notation to 3 significant figures. So I move this over 1, 2, 3, 4, and it's 4.27. Okay, the reason it's 7 light years is because the 3 does not round the 7 up, it truncates the 7. So 42,000 or 4.27 times 10 to the 4 in terms of scientific notation. All right, I need to go up, have a look here. Part C. A light year is defined to be the distance light travels in 1 year. Makes sense? The speed of light is 3 times 10 to the 8. I'm going to put that number over here. 3 times 10 to the 8. That's meters per second. Okay? So using your answer in part B, calculate the distance between star B and star C. Okay? So the distance in light years, and we want the distance in kilometers. Well, we know that speed is distance over time. Oh, that's terrible. Okay, we know the time and we know the speed. So we want to find the distance. So distance is speed times time. We have one thing here. These are light years. Okay, this is in meters per second. And what we actually want is kilometers. So keep that in mind. So speed, 3 times 10 to the 8 meters per second. You're going for 4.27 times 10 to the 4 light years. So how are we going to get this all to match up? Well, we got to get from seconds to years. So, and from meters to kilometers. So we know that there are 1,000 meters in every kilometer. Therefore, the meters cancel. Then we've got light years and seconds. Okay, so 4.27 times 10 to the 4 light years was the answer to part B. This is the speed that light travels in meters per second. Here is the distance in light years, so focus on the years here. And we wanted kilometers, not meters. So there's 1,000 meters in a kilometer. So this number will be divided by 1,000, so it can become 3 times 10 to the 4. But let's let the calculator do the work here. Okay, now we have a bit of a problem here. We have years per second, so that's not going to work. So we need to figure out there are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year. Therefore, there are a lot of seconds in a year. So this is seconds per year. So this number, I'm going to call it ants from the calculator, is in seconds per year. Okay, so years cancel, seconds cancel, and we're left with what we want. Light doesn't matter so much, which is kilometers. Okay, bit hard to follow all this last bit with the units. You might want to watch that a few times. At the end of the day though, we're taking this, multiplying by this, dividing by this, and multiplying by that answer. So let's do it a bit backwards. Answer, divide 1000, okay, times 4.27 times 10 to the 4. Notice I didn't put brackets there because we're all multiplying, so I can get away with it. Times, oops, 3 times 10 to the 8. Okay, so some large number, which is 4.04 times 10 to the 17, and our units are kilometers. Okay, 4 because after the 3 comes a 9. First digit, second significant digit, third significant digit, fourth significant digit is a 9, which makes that go up.